Hi, I'm Akash, and this is my solution for ML-powered product recommender. So I have made this for Stibo Systems Hackathon Challenge 2025, and this is my solution. So going on, I have received an XML file which had data of products. So I am converting it into something more readable right now. So we can either convert it into a JSON or some yet another markup language or a TOML or as well as a message pack. While message pack is not meant for readability, it is meant for a larger user base. So focusing on maintaining data readability, I have currently chosen transforming it into a JSON format. And as you can see, it becomes something like this. So this looks way more readable than an XML format. So moving on, yeah, as you can already see in our data set here, this is all in a nested fashion. So for fighting with a nested fashion, I'm using some sort of data set flattening. So while I have to simplify my data, I'm flattening it so that it is way more readable. And while we are doing data exploration right now, so being more readable can lead to more better insights as well as decisions. So we are making this hierarchical data set into something flat and linear. So moving on, yeah, and after looking into the data set, we can see that there's some sort of ID for the products. That is from the iStat data set, it is having this sort of name. So iStat production as well as some sort of number. So to make it more semantic, we can actually replace the ID with the name. So I'm doing the same for data enrichment so that it becomes much more readable as well as understandable for later processing as well as readability. So while I'm replacing this, this provides an important role in seeing which products are linked with which other products in a more semantic way, let's say. So I'm doing this replacement here. So going on, for getting the similarity as well as some sort of analysis for doing how one word is associated with one another, I'm using a graph-based centrality analysis. So usually the traditional techniques are a priori or FP growth as well as a TF-IDF, where we see how many words are there in one sentence as related to its frequency. So here a graph-based centrality analysis actually means that there is some sort of graph implementation along with some sort of attention mechanism you can actually find in a transformer, let's say. So this is what we use for association rule mining here. So we can take the products as some sort of nodes here as the edges are what they are linked with and how well they are linked with and their lengths. Yeah. So going on, as we already have a numerical value from the graph-based centrality, now we can actually apply some sort of ML algorithms here. So what we can do is for our recommendation system to work even better, we can use some sort of clustering or grouping algorithm. So while keeping in mind that it's a hierarchical data set, I'm actually more inclined to use something like a birch. But let's say we have some advanced algorithms like Clara, Optics, Driplet, as well as some genetic algorithms. And here are some deep learning algorithms here. So what we can do is we can actually utilize these in some sort of series to obtain a hierarchical behavior. And this is what we usually know is known as bagging in ML terms. So going on, while we have lots and lots of attribute lists in our data set, we have to use all of them for our clustering. So what I can do is I can assign all of them some sort of value so that we can actually use them inside our models as well as in our clustering. So as to do that, I'm currently using a one-hot encoding. As you can see from this Example here, this is the label encoding here, and this is being converted into a one hot encoding. And this makes it a numerical value and easier to process as well. So going on, while we have already seen all of our clustering as well as traditional ML approaches, now I want to introduce something more. Now, let's say a user has some sort of historical purchase. So while I have those data, I can analyze those historical purchases. Let's say one person buys a phone or something like a laptop, let's say. So if he buys a phone, he'll always buy something like a phone case or a screen guard, let's say. So while these are linked with phone or electronics in common, but they are never related to each other directly. But this can be done via some sort of clustering algorithms as well. But I'm using a semantic integration here. So as let's say a user also has some purchases of some applications. So if your products also include some apps, let's say, so while he's buying, let's say, a Samsung phone, so he'll also buy something usually people buy with Samsung phones, but this cannot be done through clustering. So here we can use something like LLM, like here I can implement Llama 3B or 7B locally for some sort of semantic processing as well as querying, and as well as integrate a database for product information on what's available in your own system. So moving on, I'm implementing a RAG database like this. When a client has some sort of question, it goes into the vector database and sees what all is available, and what all is available is posted to the LLM. Where the LLM sees the client's question as well as the vector database and processes it and gives the answer to what the client can actually buy more. So while we can use this semantic approach, we also have a clustering approach. So we can combine both the numerical and the semantic analysis to create a hybrid recommendation system. And I think this will be a far better approach in any of the systems so far. And this is my presentation. Thank you.